The functions f and g are defined by f of x is equal to 9 over 2x plus 1 and g of x is equal to x minus 3. Find in its simplest form an expression for f of g of x. F of g of x, as we have it here, is the composition of functions f and g. Of course, the functions f and g can be composed as f of g or g of f. And mathematically, both are not always equal. So we generally say that the composition of function is not commutative. That means the order in which we compose functions does actually affect the resulting function, which is called a composite function. Therefore, if the problem says f of g of x, we have to make sure that the functions are composed in the correct order. As a matter of fact, one common mistake that students make in examinations is that they place the wrong function into the other, or they cause the function to operate on the wrong one. So they actually do it in the wrong order, and that is a common mistake that students make. That mistake can be detrimental because the order in which we compose function does affect the resulting function. The expression is a composition of functions in which the function f is operating on the function g. There we have f operating on x, so that is f of x. Now we need f to operate on g. As we have it, the function f is operating on x. In order to show that f is operating on g, we will replace x with g. Therefore, where we see x, we will replace that with g. Therefore, we have in the header right here that f is operating on g, and also x is replaced with g in the algebraic representation of the function. Consequently, this is the result. As a matter of fact, it's just a repeat of the resulting function that we have, and we are just doing this for the sake of the animation. So we'll continue to make our substitution. G will then be replaced by its algebraic representation. Not this one, this one. So this, of course, is just saying that f is operating on g. And what we have here is 2g plus 1. Therefore, we will replace this with the algebraic representation of g, which is, of course, you can see that g of x is equal to x minus 3. Therefore, if we replace g with its algebraic representation, which is what we should do, then in the place of g that we have here, and this is what we call an error correcting code. Why an error correcting code? Because if we proceed in this manner, we will not make the mistake of substituting the wrong function into the other. The function that we have is the leading function f. So we have f of g of x. F is operating on g of x. So we begin with f is operating on x. Then we substitute the function g into the entire algebraic formation, in order that we do not make that mistake, that common mistake that students make. After substituting g, then we substitute the algebraic representation of g. And we are just required to simplify the resulting expression, and we are done. So let's go. What do we do first? We will expand the brackets. So expand the brackets first. The animation will tell us exactly what to do. Although we know that 2 should be multiplied by x, that will give us 2x. Then the same 2 will be multiplying by negative 3, and we have 2 times negative 3 is equal to negative 6, and we are demonstrating here the distributive property, which says that multiplication is distributive over addition. There's no difficulty. Anything that is unchanged will return, and we have the returning of the 9 and the plus 1 right there. Then we expand the brackets. 2 times x is 2x. 2 times negative 3 is negative 6. And of course, we will next put the negative 6 and the plus 1 together, and we are done. We will next simplify the denominator by combining the like terms. And it so happens that on this occasion, the like terms are constant terms. So we will put those together also. We'll have negative 6 plus 1, and we have it right here. Of course, the computer will tell us what to do by highlighting them, negative 6 and 1, which are the like terms, which are the constant terms. Negative 6 plus 1 is equal to negative 5. Negative 5 goes right there. And that's all there is to it. This is the result of causing the function f to operate on the function g. It is also called the composite function f of g of x, which is read. We have it right here, f of g of x, and we are saying that it is read f of g of x. And of course, we are using Euler's notation right here. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.